Hello there, this is Vinay. I am explaining question number 1 of homework 9, a probability and stochastic processes class of Professor Chen. So in the first question, we are given that Wt is a stochastic process with its mean function as 0, and the autocorrelation function for Wt is given, Wt T1 T2 is given as alpha, minimum of T1 and T2, and yt is wt minus 1 for t greater than equal to 0, and it's equal to yt is equal to 0 for t less than equal to 1. So as the definition of yt, we can write mean function for yt as ewt minus wt minus 1. This we can expand as ewt minus e of wt minus 1, and both of them will be equal to 0 as per given. Now we will find the autocorrelation function for y, that is ry t1 t2. So this will be e of yt1 into yt2. So yt1 from here, wt1 minus wt1 minus 1, yt2 will be wt2 minus wt2 minus 1, and further expanding this, multiplying these two brackets, we get mean function of wt1 into wt2 minus wt1 minus 1 into wt2 minus wt1 into wt2 minus 1, this, and wt1 minus 1, this will be minus minus plus wt1 minus 1 into wt2 minus 1. This can be further simplified, as we can separate mean function for each of these multiplications. So mean function of wt1 into wt2 minus wt1 minus 1 wt2 and so on. So this is actually an autocorrelation function. This is also actually autocorrelation function, so we will write them as autocorrelation function of t1 and t2. Similarly for all. Now the autocorrelation, this is actually autocorrelation function of w, and autocorrelation function of w is given as alpha, minimum of t1 and t2. So expanding this, alpha minimum t1 t2, alpha minimum, here t1 is t1 minus 1 and t2 minus, here t1 is t1 and t2 is t2 minus 1, and here t1 is t1 minus 1 and t2 into t2 minus 1. Now there will be many cases, so one of them is when t2 less than t1 and t2 is less than t1 minus 1. This can be seen on this axis. So minimum of from above, from here, we will solve this. So alpha minimum t1 t2 minus minimum t1 t2 minus 1, and so on. So minimum t1 t2 is t2, so here t2 from t1 and t2 minus 1, minimum is t2 minus 1, from here minimum is t2, from here minimum is t2 minus 1. And as we solve this, we see that t2 cancels t2, 1 cancels 1, and again t2 cancels t2, and we have 0 answer. So autocorrelation function of y, t1 and t2, when t2 less than t1 and t2 less than t1 minus 1 is 0. Now the case when t1 is greater than t2 plus, but t1 minus 1 is less than t2, so t2 is in between t1 and t1 minus 1. Using above the derivation we have got for ry, again autocorrelation function of y, expanding it, getting the values of this minimum function, t2 in this case minimum, in this case t2 minus 1 and then t1, so t2 will minus 1 will be minimum, here t1 minus 1 and t2, so t1 minus 1 is minimum, and here tn minus 1 and t2 minus 1, so of course t2 minus 1 will be minimum. So doing the subtractions, t2 minus 1, this cancels out this, so and 1 cancels this 1, so we get minus t1 plus t2 plus 1. So this can be written in this as alpha into 1 minus under bracket t1 minus t2 the whole bracket. Now we get, so first case was t1 greater than t2, that is mod of t1 minus t2 is greater than 1, and so in this case that is 0, and in the second case t1 minus t2 less than equal to 1, as t1 minus 1 was less than t2, so in this second case it will be alpha 1 minus as we derived here. So autocorrelation function for y, r tau, where r tau is mod of t1 minus t2 is equal to 0 when tau is greater than 1, tau is this mod of t1 minus t2, and it is alpha 1 minus tau, tau less than equal to 1. So yt is wide sense stationary. Thank you.